Welcome back, everyone. In this video, I'm going to speak with you about degrees of freedom, and we'll talk a little bit about what a t-distribution looks like. So let's go right ahead. So in this section, we're going to talk about the t-distribution, degrees of freedom, and what are the properties of the t-distribution. And in the next video, I'm actually going to show you about the t-distribution table itself. So we've talked before about how before we calculate our sample variance, we need to know our sample mean. And this process places a restriction on our variance such that only n-1 scores in a sample are free to be independent and free to vary, and that last score is determined. And n-1 is called degrees of freedom for variance. So when we talk about sample variance, we're going to use n-1 in the denominator, and we're going to call that degrees of freedom. So the principles of the t-statistic is this. The greater the value for our degrees of freedom, n-1, the better our sample variance is going to represent our population variance, and the better the t-statistic will approximate the z-statistic. So in other words, the bigger the sample size, the better the sample is going to represent the population. We've talked about this before, about how the sample size being larger is more representative of the population. So the degrees of freedom associated with sample variance, estimated sample variance, also describes how well the t-statistic represents this z-statistic. And I'm going to show you a picture of what this looks like. So the very top curve is the normal distribution, and we're all familiar with this. We've been working with this normal distribution, this z-distribution, the whole semester. But the two curves below it are samples of what a t-distribution would look like. Now, for the z-distribution, that's one distribution, but the t-distribution will look different depending on your degrees of freedom. In other words, depending on the sample size. So as you will notice, the t-distribution with degrees of freedom of 20 is closer to the normal distribution than a t-distribution with degrees of freedom of 5. So what this tells us is that as our degrees of freedom get larger, our t-distribution will more normally approximate the normal distribution. So we just need to remember that the t-distribution is going to look differently depending on the sample size, the degrees of freedom. So like the normal distribution, t-distributions are bell-shaped, they are symmetrical, and they do have a mean of 0. So that they do have in common with the normal distribution. But the normal distribution isn't affected by sample size, but the t-distribution is. The t-distribution will look different depending on the sample size. So t-distributions have more variability. You'll notice that. They are flatter. They have a more spread out shape. And that is something to just keep in mind and remember and keep in your notes. T-distributions are flatter and they have a more spread out shape than the normal distribution. And the shape and the values of the t-distribution will change depending on the degrees of freedom. So the larger the value of degrees of freedom, the more closely the t-distribution approximates a normal distribution. So lower sample sizes are going to be less like the normal distribution. So with smaller samples, the t-distribution becomes flatter and more spread out than a normal distribution. Well, why is that? So when we have a z-score distribution, the denominator isn't going to change because the population variance and sample size are the same for every sample. We know this population variance. It's not going to change. But for the t-denominator, the denominator is going to change from one sample to the next. The sample variance is going to be different for every single sample. So the estimated error will also vary. So the estimated standard error is going to be different for every single sample that we have because we can't rely on the unit normal table with the parameters that are already known. Each sample produces a different degrees of freedom. And so the boundaries for the critical regions are going to be different for every sample. So what are the things to remember? What are the important things to remember? Well, first of all, when we're talking about degrees of freedom, with the t statistic, we're talking about n minus 1, the number in the sample minus 1. Another thing to remember is that the t distribution is very much like the z distribution, but it's flatter and it has more variability. And perhaps the most important thing to remember is that as our sample size increases, our t distribution is going to look more like the normal distribution. Okay, in the next video, I'm going to show you the t distribution. See you there.